every irreducible polynomial in f of x. If you take any polynomial in f of x, if you take any polynomial in f of x, then if f of x has any root in k, that means if alpha belongs to k such that f of alpha is equal to 0 aithe, then f splits into linear factor. So that means f splits into k, either linear kaavachu non-linear kuda kaavachu. So every root of the polynomial f of x must belongs to k aithe, then k is called normal extension. సో ఏదైనా ఒక రూట్, ఏదైనా ఒక పాలినామియల్ f లో తీసుకొని అండ్ k లో ఒక రూట్ ఎగ్జిస్ట్ అయింది అనుకోండి, దెన్ ఎవ్రీ రూట్ ఆఫ్ f of x షుడ్ బిలాంగ్స్ టు k కావాలి. ఇన్ సచ్ కేస్ k is called a normal extension. Definition. An algebraic extension k over f is called normal extension. If every irreducible polynomial in f of x, if f of alpha is equal to 0 in k, then f splits into over k. F splits over k. That means every root of f of x is belongs to k. Every root of f of x is belongs to k, then k is called normal extension of f. Examples: q root 2 sir, over q, right? Q root 2 over q. So what is the minimal? So assume that some x is equal to root 2. So its minimal polynomial is x square minus 2, which is belongs to q over x, right? So which can be written as x, the linear factor center x minus root 2 into x plus root. So therefore plus or minus root 2 r belongs to q root 2. So therefore the polynomial x square minus 2 is belongs to q of irreducible in q of x, and every factor is belongs to q root 2. That means every root of the polynomial x square minus 2 is belongs to q root 2. So q root 2 is the normal extension of q. So that means x square minus 2 splits into q root. And the factors ga rastunnam. So therefore q root 2 is normal extension of q over q. In a similar way, q root d where over q, where d is square field. D is square field is always is normal extension. Is a normal extension. If d is equal to ఏదైనా substitute చేయండి. If d is square field, substitute d is equal to 2, 3, 5, 6, 7, 9, 10, 11, etc. All are normal extensions. What about this one? Cube over I over Q is normal extension. Yes or no? So what is the minimal polynomial of I, sir? Let alpha is equal to I. So we need to find the minimal polynomial. X square equal to minus 1. So x square plus 1. So which is belongs to q over x. So therefore, x square plus 1 equal to x minus I into x plus I. So which splits in q over I. Right? So which splits into q over here. Therefore, x square plus 1 splits into q over I. So therefore, q over I is, so every root of this polynomial is belongs to q over I. So q over I is normal extension of q sub. So similarly, C over R is also normal extension. What about this one? Q of cubic root of 2 over Q is normal extension.
Cube minus 2.
Cubic root of 2 is a normal extension. Is it yes or no? But ఇంతకు ముందు చెప్పాను సార్ separable. It is separable extension అవుతుంది. But is it normal? మనకు నార్మల్ కావాలంటే ఏం కావాలి సార్? Every root of the polynomial generated by that element. So let alpha is equal to answer cubic root of 2. So its minimal polynomial x తీసుకోవాలి. So x cube is equal to 2 అవుతుంది. So x cube minus 2 is belongs to q over x, right? Which is the irreducible polynomial in q of x. So the roots of this one, x cube equal to x minus 2 power 1 by 3, 1 by 3, and x minus 2 power 1 by 3 into omega, and x minus 2 by 2 power 1 by 3 into omega squares. So these factors is also belongs to q of 2 power 1 by 3.
No.
So this is not splits into q of 2 power 1 by 3 because of these factors are complex numbers. These are the complex ones. But this one is real, sir. Cubic root of 2 is a real root. So therefore 2 power 1 by 3 omega, 2 power 1 by 3 omega square does not belongs to q of cubic root of 2. So therefore, all the roots of the polynomial is not belongs to the extension field. So therefore, it is not normal extension, sir, but it is a separable extension. So therefore, not normal. So which is an example of separable extension, but not normal extensions. మనం ఆల్రెడీ డిస్కస్ చేసినాం ఇది. It is a separable extension. So therefore, q of cubic root of 2 over q is separable extension, but not normal extension. సో నార్మల్ ఎక్స్టెన్షన్ అంటే ఏమన్నట్టు, ఎవ్రీ రూట్ అనేది ఏదైనా ఒక పాలినామియల్ క్యూ ఆఫ్ ఎక్స్ లో తీసుకుంటే ఎవ్రీ రూట్ ఆఫ్ దట్ ఎక్స్టెన్షన్ ఫీల్డ్ లో ఉండాలి. దట్ మీన్స్ ఎవ్రీ స్ప్లిట్టింగ్ ఫీల్డ్ ఈజ్ ఎ నార్మల్ ఎక్స్టెన్షన్. మనం ఆల్రెడీ నిన్న డిస్కస్ చేసాం. స్ప్లిట్టింగ్ ఫీల్డ్ అంటే ఏంటి సార్? ఏంటి సార్ స్ప్లిట్టింగ్ ఫీల్డ్ అంటే? అన్ని ప్రాబ్లమ్స్ సాల్వ్ చేసినాం స్ప్లిట్టింగ్ ఫీల్డ్ లో. every polynomial can be split into linear factors. And all the roots of the polynomial is belongs to that extension field, then it is called a splitting field. Kada? So therefore, every splitting field is a normal extension. Number 6. Every splitting field is a normal extension. And every quadratic extension that means the degree of E over F is equal to 2, then it is called a quadratic extension. So that means every quadratic extension is normal. Every quadratic extension is normal extension. And 8th one, the nth roots of unity over Q, where Xn is nth roots of unity. Is also normal. Is also normal. Number 1, suppose F, K, E are tower fields. That means F is subset of K, K is subset of E, and then K is subset of E. And if E over F is normal, that means E over F is normal, and then which implies E over K is normal. E over K is normal, but K over F need not be normal. Need not be normal. కొంచెం ఇది మళ్ళీ రాస్తాను సార్. So E over F is normal, which implies E over K. Sorry. E over K is normal. E over K is normal, but K over F. K over F is need not be normal. Need not be normal. It is theorem statement, sir. So I don't want to prove here. So I will give the counter example for this one. So for an example, Q is subset of Q root 2. Q root 2 is subset of, sorry,
root 2 root 3.
Cubic root of 2. Cubic root of 2. Which is subset of Q of cubic root of 2 comma omega. Comma omega. So therefore, cubic root of 2 comma omega over Q is normal. ఇంతకు ముందే డిస్కస్ చేసిన కదా, ఇట్ ఈస్ నార్మల్, బట్ దిస్ వన్ ఈస్ నాట్ నార్మల్. డిస్కస్ చేయలేదా? సో సపరేబుల్ ఎక్స్టెన్షన్ డిస్కస్ చేసినట్టు. సో ఇట్ ఈస్ నార్మల్ సార్. సో దీని యొక్క మినిమల్ పాలినామియల్ దీని ఫిట్స్ ఇంటూ దిస్ వన్ అవుట్. సో ఇట్ ఈస్ నార్మల్, అండ్ which implies this one over this one, cubic root of 2 over omega over cubic root of 2 is normal. ఎందుకు? దీని యొక్క మినిమల్ పాలినామియల్ ఏంటి సార్? x square plus x plus 1 splits into this one. So therefore it is normal, but q of cubic root of 2 over q is not normal. Above example. So Q of cubic root of 2 over Q is not normal. And you can discuss just on this one. So therefore, if Fk are tower fields, that means F is subset of K is subset of E, and E over F is normal, then E over K is normal, but K over F need not be normal. Need not be normal. Next one. Next one. Galois group. Important one. Galois group or Galois extension. Galois extension. First of all, we need to discuss about F automorphisms. F automorphism. That means ring homomorphisms from the field F to F. Ring isomorphism from the field F to F. It's called a F automorphism. Suppose let K be the finite extension over F. Let K be the finite extension over F. The group of all F automorphisms on K is denoted by automorphisms of K over F, or sometimes automorphisms of K and denoted as, and is the group of all, which is the group of all automorphisms sigma from K to K. Automorphism sigma from K to K that fixes the field. Capital F. That fixes the field capital F. Then the automorphism of K of F forms a group with respect to composition of functions. But F automorphisms ante where sigma is an automorphism from the field K to K, and this automorphism fixes the field F1. That means, suppose if you assume a automorphism from the field K to K. So this is the field K, sir. This is K, which is an extension field of F. Kada. So assume this is F, and this one is also F. Okay. Assume F contains some elements. కొంచెం పెద్దగా రాద్దాం. So this is F, and this one is F, and this is E, and this one is E. So we need to find an automorphism sigma. Okay, where sigma is an automorphism from E to E, and the elements of F. Suppose 1, 2, 3 elements F lo 1, 2, 3, and 4, 5 are extensions long, and this is 4, and this is 5. So every element of F should be the fixed map, sir. That means 1 goes to 1A, 2 goes to 2A, 3 goes to 3A. But outside F ఏదైనా ఎలిమెంట్ ఉంటే అది మేబీ మ్యాప్స్ టు ఐదర్ 4 or 5. సో 4 మ్యాప్స్ టు 5 కావచ్చు, లేదా 5 మ్యాప్స్ టు 4 కావచ్చు. బట్ ఎఫ్ లో ఉండే ఎలిమెంట్స్ మాత్రం ఫిక్స్డ్ ఇమేజింగ్ కలిగి ఉంటాయి, రిమైనింగ్ మేబీ చేంజెస్. సో సచ్ టైప్ ఆఫ్ ఆటోమార్ఫిజమ్స్ ఫార్మ్స్ ఏ groups are which is called automorphisms of the extension field K over F. K over F. అర్థమైంది ఏమన్నా? సో ఇది ఏ ఆటోమార్ఫిజం అన్నా తీసుకోండి. సపోజ్ సిగ్మా ఇస్ అన్ ఆటోమార్ఫిజం. సో సిగ్మా ఇస్ అన్ ఆటోమార్ఫిజం అంటే ఓవర్ ద ఫీల్డ్ అండి. దట్ మీన్స్ సిగ్మా ఇస్ ఏ ring homomorphism. So that means sigma of x plus y should satisfy sigma of x plus sigma of y, and sigma of x plus y is equal to sigma of x into sigma of y, and third condition is sigma of some alpha is equal to alpha for every alpha belongs to capital F. If any sigma satisfies these three conditions, and also ఏమన్నాడు ఆటోమార్ఫిజం అన్నాడు. That means sigma from k to k is biject. అయితే then the set of all such automorphisms forms a group, and that group is called automorphisms K over F. If automorphisms of K over F, and if the splitting field is a normal extension, then the automorphisms group is called a Galois group.
Sorry, the sigma x y x plus y.
X into y. Ring homomorphism, sir. Sigma is nothing but field to field అంటే ring homomorphism కావాలి ఫస్ట్, అండ్ బైజెక్టివ్ కావాలి, దెన్ ఇట్ ఈస్ ఆటోమార్ఫిజం అవుతుంది. సో ఎందుకు సేమ్ సెట్ యొక్క డొమైన్ అండ్ కోడొమైన్ కాబట్టి ఎవ్రీ ఐసోమార్ఫిజం ఫ్రమ్ ద ఫీల్డ్ F2 itself is called a automorphism. So therefore sigma is an isomorphism, and sigma of alpha is equal to alpha for every alpha belongs to F అయితే then it is called the set of all such automorphisms forms a group, and it is called a Galois group. It is called a Galois group. And the automorphisms of K over F forms a group with respect to composition of functions. Composition of function. Right? Note. If E is the finite extension, if E is the finite extension of the field F, then order of automorphisms of K over F, which is always less than or equal to the degree of the extension field E over F. The degree of the extension field E over F. If it is a Galois group, if automorphisms of K over F is an Galois group అయితే then these two are equals. అది మనకు నెక్స్ట్ వస్తుంది. If it is a Galois group, then both are equal. Otherwise, if it is not Galois, then these two are not equals. అది ఎప్పుడు అవుతుంది? Next one, Galois extension. Galois extension. Let K over F be a finite extension. Is a finite extension. Then K is said to be, and K is said to be Galois over F. Galois over F, and K over F is called Galois extension. Galois extension if the order of automorphisms of K over F is equal to the degree of E over F. The degree of E over F. In this case, the automorphisms of K over F is called Galois group. It's called Galois group of K over F, and it is denoted by Galois group of K over F. Galois group of K over F. ఇది ఎప్పుడు order of automorphisms K over F should be equal to E over F అయితే then it is called a Galois group, sir. Otherwise it is not Galois group. Not. If K is a splitting field, over F of separable polynomial, then K over F is Galois. ఎందుకు? K over F is separable, which means every splitting field of over F and every splitting field over F is normal extension, sir. Every splitting field over F is a normal extension and it is also separable. That means every Galois field is separable and also normal extension. It is an if and only if condition. Let K over F is finite extension, then K over F is Galois. That means Galois extension if and only if K over F is both separable and normal. So K over F ఈ రెండిట్లో ఏది ఫెయిల్ అయినా then it is not Galois. Next one, every quadratic extension. That means the degree of E over F is equal to 2, sir, is Galois. The next one, the Galois of F over itself is always isomorphic to Z1, where F is a field. So this is true whenever the characteristic of F is not equal to. So every quadratic extension is Galois whenever the characteristic of F is not equal to. Problems. Number 1, C over R is Galois extension. If so, then what is an automorphism? So Galois extension కావాలంటే then we need to find a automorphism from C to C. Solutions. Suppose define an automorphism sigma from C to C such that ఏం కావాలి సార్? Assume that ఇది automorphism అనుకుందాం. Let sigma from C to C is an automorphism. C లో ఎలిమెంట్స్ ఏ విధంగా ఉంటాయి? C is equal to set of all elements of the form A plus IB such that A comma B belongs to R. Kada? So therefore, and sigma is an automorphism kabatti sigma of x plus y is equal to sigma of x plus sigma of y. And number 2, sigma of x into y is equal to sigma of x into sigma of y, and it is bijective. Kada? So therefore, now we need to find the image of an element in CSIR. So and also sigma of A is equal to A for every A belongs to R. అంటే ఏదైనా ఒక రియల్ నెంబర్ ఉంటే దాని యొక్క ఇమేజ్ ఏనే సార్, బికాస్ ద ఫీల్డ్ ఆర్ ఇస్ ఫిక్స్డ్ సార్ విత్ రెస్పెక్ట్ టు ద ఆటోమార్ఫిజం, రైట్ సార్. సో దేర్ ఫోర్ నౌ ఫైండ్ ది ఇమేజ్ ఆఫ్ an element in C. So A plus IB and us. A plus IB. So which is equal to sigma is an automorphism. So which is equal to sigma of A plus sigma of I into B. So which is equal to, but A and B are real numbers, right sir? A and B are real numbers. So sigma should fix every real number. So sigma of A is equal to A by the definition, and plus sigma of I into B sir by the second condition. This value equal to sigma of I into sigma of B sir. So which is equal to A plus, where I is the complex number, so we need to find the image of I, and into sigma of B, where B is belongs to R. So B is belongs to R కాబట్టి by this condition sigma of B is equal to B. So based on the definition of sigma of Y, then we can find the different automorphisms. So then what is sigma of I? So now we need to find the image of I. Okay, so but we know that I square is equal to -1. But we know that I square equal to -1, and sigma is an automorphism. So sigma of I square equal to sigma of -1. Sigma of I square equal to sigma of -1. So sigma is an homomorphism. So sigma of I whole square equal to sigma of I whole square, and sigma since -1 is belongs to R. So therefore sigma of -1 equal to -1. So therefore which is equal to -1. So which implies sigma of I is equal to -1 whole power 1/2. Avuna? So which is nothing but plus or minus I. Which is nothing but plus or minus I. So sigma of I is equal to plus I, and sigma of I is equal to minus I. So suppose if sigma of I is equal to I అయిందనుకోండి, then sigma of A plus IB ని ఏ విధంగా డిఫైన్ చేస్తాం? Sigma of A plus sigma of I అంటే I into B. So that means sigma of X equal to X అండి, which is an identity automorphism. And if sigma of I is equal to minus I అయిందనుకోండి, which implies sigma of A plus IB is equal to A minus of IB. So which implies sigma of X is equal to conjugate of this complex number, sir, which is equal to X bar. So therefore there exist two automorphisms. So therefore the automorphisms of C over R is equal to sigma 1, where sigma 1 is an identity homomorphism, and sigma 2 sir, sigma 2. So here దీని స్క్వేర్ చేయండి సార్, సిగ్మా స్క్వేర్ ఆఫ్ ఎక్స్. ఇఫ్ సిగ్మా ఆఫ్ ఎక్స్ ఈక్వల్ టు ఎక్స్ బార్ అయితే సిగ్మా స్క్వేర్ ఆఫ్ ఎక్స్ ఏమవుతుంది? సిగ్మా ఆఫ్ ఎక్స్ కదా. సో సిగ్మా ఆఫ్ ఎక్స్ అంటే ఎక్స్ బార్, మళ్ళీ సిగ్మా ఆఫ్ ఎక్స్ బార్ అంటే ఎక్స్ బార్ హోల్ బార్ సార్, విచ్ ఈజ్ ఈక్వల్ టు ఎక్స్ సార్. సో దట్ మీన్స్ sigma square equal to I sir. So order of this one equal to 2, and this is an identity, so order equal to 1. So which is isomorphic to Z? Which is isomorphic to Z? So therefore the automorphisms of C over R is isomorphic to Z2, and therefore the order of automorphisms of C over R, that means the Galois, which is equal to order of Z2, so which is equal to 2. Right sir? And next we need to find the degree of C over R. So C over R equal to the dimension of C over R. And then ఎక్స్టెన్షన్ ఫీల్డ్ యొక్క ఆర్డర్ ఈక్వల్ టు సిని వెక్టర్ స్పేస్ గా కన్సిడర్ చేయండి. ఇది ఓవర్ ఆర్, సో విచ్ ఈజ్ ఈక్వల్ టు డైమెన్షన్ ఆఫ్ సి ఓవర్ ఆర్, సో విచ్ ఈజ్ ఈక్వల్ టు 2. Therefore these two are equal. So order of automorphism C over R is equal to order of C over R, right? So therefore C over R is Galois. So this is a Galois extension. Yes. If these two are not equal, then it is not Galois. Right? Next one. Q root 2 over Q is Galois extension. Is it yes or no? చెప్పండి సార్. So what is Q root 2, sir? Q root 2 equal to A plus B root 2 kada, such that A comma B belongs to Q1.
Center.
Okay. So Galois extension అవుతుందా కాదంటే of course it is separable and also normal అవుతుంది సార్. Q root 2 over Q is separable and also ఇలా కూడా చెప్పొచ్చు. So Q root 2 over Q is separable extension, right? And also normal. So which implies Galois. Honey, now I need to find this automorphism group is isomorphic to A group ఉంటే అది ఫైండ్ అవుట్ చేయండి. So now define an automorphism sigma from Q root 2 to Q root 2. Q root 2 to Q root 2 be an isomorphism అనుకుందాం. So images of A plus B root 2 కదా దీంట్లో ఉండే elements. So which is equal to ఏం కావాలి సార్? Since it is an isomorphism, so sigma of A plus sigma of B into 2. So which is equal to sigma of A plus sigma of root 2 అంటే 2 power 1 by 2 రాస్తున్నా into sigma of B. So ఎందుకు? By the ring homomorphism definition, sigma of A plus B is equal to sigma of A plus sigma of B, and sigma of A into B is equal to sigma of A into sigma of B, sir. So I need ఈ రెండు ఇక్కడ అప్లై చేస్తుంది. So sigma of A into B is equal to sigma of A into sigma of, right? So here A and B are belongs to Q, sir. కాబట్టి sigma of A Q ని ఫిక్స్ చేస్తున్నాం కాబట్టి this value is equal to image of sigma of A is equal to A plus sigma of 2 power 1 by 2 into sigma of B is equal to B. So our aim is to find image of this one. So based on image of this one, we can find the number of automorphisms. So suppose 2 power 1 by 2 undi, let x which is equal to alpha. Okay, sir. So which implies alpha square is equal to 2, sir. Alpha square equal to 2. So mute చేసుకోండి సార్ ఎవరు. So sigma of alpha square equal to sigma of 2, sir. Since it is 1 1 1 1 కాబట్టి sigma of alpha square equal to sigma 2 అవుతుంది. So sigma of alpha, since sigma is an automorphism, so sigma of alpha square equal to sigma of alpha whole square, and sigma of 2 is a real number, sorry, rational number. So sigma of 2 is equal to 2, sir. Right? Sigma of 2 is equal to 2. So which implies sigma of alpha is equal to 2 power 1 by 2, sir. 2 power 1 by 2 అంటే 2 power 1 by 2 into second units of square units of 1, sir. That means 2 power 1 by 2 comma minus 2 power 1 by 2. 2 power 1 by 2 is equal to, and that means under root of 2 is equal to plus or minus 2 power 1 by 2 and minus 2 power 1 by 2. These are the roots. So therefore sigma of alpha is equal to either alpha, that means plus or minus alpha అనొచ్చా. సో ఇది ఆల్ఫా అయితే ఇది మైనస్ ఆల్ఫా. సో sigma of alpha is equal to plus or minus alpha. So therefore sigma of a plus b root a plus b root 2 ఏ విధంగా డిఫైన్ చేస్తున్నాం?
Plus or minus a plus.
సో a plus b root 2 ఆల్ఫానే, అండ్ ఇది sigma 1, another one is sigma 2 equal to a plus b root 2 into equal to a minus of b root, a minus of b root. So therefore these two,
Minus
therefore
ఏముంది?
automorphisms of q root 2 over q is equal to sigma 1 comma sigma 2. So sigma 2 square equal to identity of this. So therefore which is group of order 2, so which is isomorphic to z, which is isomorphic to z2. So therefore order of which is a Galois group, so the Galois group of q root 2 over q order is equal to 2, is equal to note the automorphisms of q root d over q, the order లేదా this group గా తీసుకుంటే it is isomorphic to z, it is isomorphic to z where d is square free, d is a square free. ఒకవేళ d అనేది స్క్వేర్ అయింది అనుకోండి, q root d is equal to, suppose d is equal to 4 తీసుకున్నాం, సో q root d ఏమవుతుంది, root 4 అవుతుంది. సో q of 2 అవుతుంది సార్, q of 2 is nothing but q, సార్. సో q over q is equal to z1 అవుతుంది. ఓకే
సార్ ఇక్కడ పైన ప్లస్ ఆర్ మైనస్ ఆల్ఫా అన్నారు కదా,
అవునండి.
sigma of alpha. అక్కడ కొంచెం ఇక్కడ ఇది మైనస్ ఏ కూడా వస్తుందా, లేకుంటే ఓన్లీ
మైనస్ ఏ ఇక్కడ ఆల్ఫా అంటే ఏంటి సార్, ఆల్ఫా ఇస్ నథింగ్ బట్ 2 power 1 by 2, మైనస్ ఏ రాదు.
ఇది ఏ ప్లస్ బి రూటే కదా సార్ ఆల్ఫా అంటే?
ఏ ప్లస్ బి రూట్ కాదు సార్, ఆల్ఫా ఈజ్ 2 power 1 by 2 అండి ఇక్కడ అనుకున్నాను.
ఇక్కడ ఈ దానికి ఓకే, నేను ఏ ప్లస్ బి రూట్
కాదండి కాదు. So therefore automorphisms of R Galois group of q root d over q is isomorphic to z1. So the Galois group of q root d over q, sometimes we can denote it as Galois group of q root d and good, so which is isomorphic to z. q ని మెన్షన్ చేయకుండా డైరెక్ట్ ఎక్స్టెన్షన్ ఫీల్డ్ మెన్షన్ చేస్తాం. నెక్స్ట్ వన్, the Galois group of q root 2 root 3 over Q is dash. Of course, it is Galois of the Q root 2 root 3 is normal extension and also separable extension. Discuss. So every normal and separable extensions are Galois because of finite extensions. Q root 2 root 3 is a finite extension of Q. So therefore, it is separable and also normal. So it is Galois. ఎందుకు మనం ఆల్రెడీ ఫైండ్ అవుట్ చేసినాం సార్ దాని యొక్క డిగ్రీ ఎంత ఓవర్ క్యూ ఈజ్ ఈక్వల్ టు 4 కదా మనం ఆల్రెడీ ఫైండ్ అవుట్ చేసినాం సో ఫైనైట్ నెంబర్ కాబట్టి ఇట్ ఈజ్ ఎ ఫైనైట్ ఎక్స్టెన్షన్ సో algebraic extensions కాబట్టి every algebraic finite extensions are Galois if it is separable కాబట్టి Galois అవుతుందా కాదని పక్కకి పెట్టండి సో now we need to define the homomorphisms అవునా దీంట్లో ఉండే ఎలిమెంట్స్ ఏ విధంగా ఉంటాయి q root 2 root 3
a plus b root 2 plus c root 3
a plus
b root 2 c root 3
plus c root 3
plus b root
6 root 3 into root 3 such that a b c d belongs to అవునా a b c d belongs to q so now we define sigma from so దీని some k అనుకుంటున్నాం సార్ ఈ లెంత్ ఎందుకు రాయడం అని suppose assume that k is equal to q root 2 root 3 so sigma from k to k is an automorphism so that means sigma of an element x is equal to direct element of the form. So what is x? X is equal to a plus b root 2 power 1 by 2 plus c into 3 power 1 by 2 plus d into 2 power 1 by 2 into 3 power 1 by 2. So which is equal to sigma of a plus so దీన్ని alpha అనుకుంటున్నా దీన్ని beta అనుకుంటున్నా ఓకేనా let here alpha is equal to 2 power 1 by 2 and beta is equal to 3 power 1 by 2 and sigma of b into alpha plus sigma of c into beta plus sigma of d alpha beta but a b c d are rational numbers so rational numbers ni fixed images ఉంటాయి కాబట్టి sigma of a is equal to a and sigma of b into alpha is equal to by second homomorphism property sigma of b into alpha is equal to sigma of b into sigma of alpha sir but sigma of b is equal to b కాబట్టి b into sigma of alpha ras plus c into sigma of beta plus d into sigma of alpha into sigma of beta. So now I need to evaluate two values sigma of alpha and sigma of beta kada sigma of alpha and sigma of beta where alpha is equal to 2 power 1 by 2 beta is equal to 3 power 1 by 2 3 power 1 by 2 so therefore alpha square చేస్తే ఏమవుతుంది alpha square equal to 2 beta square equal to 3 sir so now apply the sigma on both sides sigma of alpha square equal to sigma of 2 and sigma of beta square equal to sigma of 3 and 2 comma 3 are rational numbers so rational numbers has a fixed images so which is equal to 3 so which is equal to sigma of beta whole square and this one is sigma of alpha whole square so therefore sigma of alpha is equal to 2 power 1 by 2 and sigma of beta is equal to 3 power 1 by 2 right so 2 power 1 by 2 ante under root of 2 sir then your roots in the 2 power 1 by 2 and minus 2 power 1 by 2 and sigma of beta is equal to 3 power 1 by 2 and 3 power minus 3 power 1. So alpha ki sigma of alpha ki 2 choices ఉన్నాయి, sigma of beta ki 2 choices ఉన్నాయి. So that means sigma of alpha is equal to minus alpha and sigma of beta is equal to minus beta. So define చేసుకుంటే then there exist four automorphisms and ఇప్పుడు సిగ్మా స్క్వేర్ ఏమవుతుంది, సిగ్మా స్క్వేర్ ఆఫ్ ఆల్ఫా ఈక్వల్ టు ఏమవుతుంది సార్, ఇది మైనస్ ఆల్ఫా అంటే సిగ్మా
minus sigma of alpha.
minus alpha equal to minus of minus alpha equal to alpha. That is identity. And similarly, sigma square of beta is equal to identity. So sigma square equal to identity of alpha equal to identity. Sigma square of beta is equal to identity. లేదంటే ఇది సిగ్మా నుండి ఇది టౌ అని, టౌ ఆఫ్ బీటా is equal to minus beta. So టౌ స్క్వేర్ equal to beta. సో మనకి ఏమేమి ఎన్ని ఉన్నాయి, సిగ్మా ఏ విధంగా డిఫైన్ చేసినాం, మ్యాప్స్ టు 2 power 1 by 2 to 2 power 1 by 2. నెక్స్ట్ ఇంకేముంది, ఓన్లీ 2 power 1 by 2 ఉంది, 2 power 1 by 2 1 by 2 ఒకటి సిగ్మా 1 అండ్ ఇక్కడ 3 power 1 by 2 goes to 3 power 1 and 2 power 1 by 2 goes to minus 2 power 1 by 2 ఇది సేమ్ సార్. నెక్స్ట్ 2 power 1 by 2 goes to 2 power 1 by 2 and 3 power 1 by 2 goes to minus 3 power 1 by 2 and 2 power 1 by 2 goes to 2 power 1 by 2 and 3 power 1 by 2 goes to minus 3 power 1. So then you will get sigma 2, sigma 3, sigma 4. Okay. So therefore automorphisms of q root 2 comma root 3 over q is equal to sigma 1, sigma 2, sigma 3 and sigma 4. So this one is an identity, sir. So then square చేసిన అనుకో identity. So each sigma 2 square equal to identity వస్తుంది, sigma 3 square is also equal to identity and sigma 4 square is also equal to identity. ఇది అలాగో ఐడెంటిటీ మ్యాప్ అయింది, దీన్ని స్క్వేర్ చేస్తే మళ్ళీ 3 power 1 by 2 కి వస్తుంది.
మైనస్ సార్
ఏది
సిగ్మా 4 2 4 2 మైనస్
ఇది ప్లస్ ఇది మైనస్, ఇది ప్లస్ ఇది 2 minus 2 ఇది మైనస్,
ఇది మైనస్ 2 పవర్
minus. Yes. So therefore this one is a plane 4 group. ఎందుకు sigma 1 square is every element of order 2 నే ఉన్నాయి. So which is isomorphic to Z2 cross Z2, which is isomorphic to Z2 cross Z2. So therefore the Galois group of q root 2 comma root 3 over q is isomorphic to Z2 cross Z2. Root 2 comma root 3 అని అవసరం లేదు, d1 comma d2 where d1 d2 are square free అయ్యి then q of this one is equal to isomorphic to Z2 cross Z2. Not only root 2 root 3 and d1 d2 are independent అయ్యి d1 d2 are square free అయితే then q of under root of d1 d2 over q is isomorphic to Z2 cross Z2. Z2 class Z2 class Z2. Next one, the extension field. The extension field q of cubic root of 2 over q is a Galois field. No, already చెప్పాను సార్. So this one cubic root of 2 over q So the minimal polynomial of x2 minus 2 belongs to q of x is minimal. But 2 power 1 by 3 comma omega into omega comma 2 power 1 by 3 into omega square that belongs to q of cubic root of 2, which implies not normal. Right? So normal కావట్లేదంటే not Galois. Not Galois. లేదా మనకి ఇంకో రకంగా కూడా చెప్పొచ్చు. ఏంది అది? The order of automorphisms of k over f
not equal.
is less than the degree of e over f. Sorry, k over f. The degree of k over f. అయితే then it is not Galois. Find out చేద్దాం. So suppose define a automorphism from q of cubic root of 2 to q of cubic root of 2 be an automorphism. Right? So cubic root of 2 elements ఏ విధంగా ఉంటాయి?
a plus b to power 1 by 3.
Where q of cubic root of 2 is equal to a plus b into 2 power 1 by 3 plus c into 2 power 1 by 3 whole square is nothing but 2 by 3 plus d into ఇప్పుడు ఇది ఏ అనుకుందాం అనుకోండి, ఇది ఆల్ఫా ఈజ్ ఈక్వల్ 2 power 1 by 3 అంటే దీని యొక్క పవర్స్ అన్ని దీనిలో ఉంటాయి సార్. ఓకే, ఇఫ్ ఆల్ఫా స్క్వేర్ వరకు ఉంది, ఇఫ్ ఆల్ఫా క్యూబ్ చేసినాం అనుకోండి అప్పుడు ఏమైతే 2 అవుతుంది సార్. దెన్ 2 అంటే ఆటోమేటిక్లీ ఇట్ ఈస్ ఎ రేషనల్ నెంబర్ కాబట్టి ఏతో ఈక్వల్ అవుతుంది. ఇఫ్ ఆల్ఫా పవర్ 4 చేసినాం అనుకో అప్పుడు ఏమవుతుంది 2 into 2 power 1 by 3 సార్. సో 2 బిలాంగ్స్ ఇది ఈ 2 power 1 by 3 కి లీనియర్ మల్టిపుల్ అవుతుంది కాబట్టి దెన్ ఇట్ ఈస్ దీస్ టూ ఆర్ ఈక్వల్స్. కాబట్టి నువ్వు ఎన్ని పవర్స్ చేసినా దెన్ దిస్ వన్ ఈజ్ ఈక్వల్ టు దిస్ సచ్ దట్ ఏబిసి ఈజ్ బిలాంగ్స్. సో ఈ మూడే వేరియబుల్స్ ఉంటాయి. సో therefore and 1 2 power 1 by 3 2 power 2 by 3 are the basis elements for q of cubic root of. So take any element in this and find the image. So sigma of a plus b into 2 power 1 by 3 plus c into 2 power 2 by 3. So which is equal to sigma of a plus b into sigma of b into 2 power 1 by 3 plus sigma of c into 2 power 2 by 3. So which is equal to where a, b, c are rational numbers. So images of rational numbers is same. So a plus b into sigma of 2 power 1 by 3 plus c into sigma of 2 power 2 by 3. Sigma of 2 power 2 by 3. So which is equal to a plus b into sigma of 2 power 1 by 3 plus 2 power 2 by 3 can be written as 2 power 1 by 3 whole square, sir. So c into sigma of 2 power 1 by 3 whole square. So అంటే మనం ఇక్కడ 2 sigma 2 power 1 by 3 ఇమేజ్ ఫైండ్ అవుట్ చేస్తే సరిపోతుంది. రైట్? సో let alpha is equal to 2 power 1 by 3, then cubic on both sides. Alpha cube is equal to 2, sir. So apply the sigma on both sides. Sigma of alpha cube is equal to sigma of 2, sir. Since 2 is a rational number, image of rational number is 2, right? So therefore which is equal to sigma of alpha cube is nothing but sigma of alpha whole cube. So which implies sigma of alpha is equal to 2 power 1 by 3 into 1 power 1 by 3, right? So which is equal to 2 power 1 by 3 into 1 comma 2 power 1 by 3 into omega and 2 power 1 by 3 into omega squares. These are the three roots, but these roots are not belongs to the extension fields. So does not belongs to q of cubic root of 2. So therefore the only possibility is this one. The only possibility is this one. So therefore sigma of alpha is equal to 2 power 1 by 3. So therefore sigma of a plus b into 2 power 1 by 3 plus c into 2 power, sorry, c into 2 power 2 by 3, which is equal to a plus b into 2 power 1 by 3 plus c into 2 power 2 by 3. So which is nothing but identity transformation, identity operation, right? So sigma of x equal to x for every x belongs to q of cubic root of 2. So which is that means the automorphisms of q of cubic root of 2 over q is equal to sigma 1 where identity transformation. So which is isomorphic to Z, which is isomorphic to Z1. So therefore, the order of automorphism group q of cubic root of 2 over q is equal to 1. But the degree of E, where E is equal to cubic root of 2 over q is equal to enta, sir? The degree of the minimal polynomial, cubic root of 2 equal to 3.
3.
So 3. So therefore, order of automorphisms of E over F is less than E over F. Idi 1, idi 3. So therefore, not Galois. So therefore, q of cubic root of 2 over q is not Galois field. Any doubts? Your doubts, sir?